Physics Part 125. The rule that the upthrust acting on body immersed in a fluid is equal to the weight of the fluid displaced is known as Archimedes' principle. Archimedes' principle will provide you the details of the Archimedes' principle. Section summary. Density P is defined by the equation P is equal to m over v, where m is the mass of an object and v is its volume. Pressure P is defined by the equation P, F is equal to A, where F is the force acting perpendicularly to an area A. The total pressure P at a point at a depth of h below the surface of a fluid of density P is equal to PA plus PGH, PA being the atmospheric pressure. The difference in pressure between the surface and at a point at a depth h is PGH. The upthrust on a body immersed in a fluid is equal to the weight of the fluid displaced. What are the section questions? The water in a storage tank is 15 meters above a water tap in the kitchen of a house. Calculate the pressure of the water leaving the tap. Density of the water is equal to 1.0 into 10 power raised to 3 kilogram per mass cubic. We've got few exam style questions for you. Number 1, over the range of temperature between about 250 K to 450 K, the resistance of R of a certain platinum wire is given. A certain solid melts at 150 degrees Celsius. Calculate the resistance of the wire at this temperature. 1b, if the wire were used as a resistance thermometer, calculate the melting point of the solid on the empirical centigrade scale of this thermometer. Number 2, consider the mole of a gas at a standard temperature at pressure 273 K and 1.01 into 10 power raised to 5 Pa. Calculate the number of molecules there are per cubic meter of the gas. Calculate the average distance apart of the molecules. If the diameter of the molecule of this gas is about 2.5. Question number 3, in the ideal gas equation PV is equal to nRT, could one use values of Celsius temperature instead of the thermodynamic temperature by using an appropriate value R of the molar gas constant? Number 4, a volume of 1.50 into 10 power raised to 3 meter cubic of hydrogen at a pressure of 2.00 10 power raised to 5 Pascal and a temperature of 30 degrees Celsius is heated until both volume and the pressure are doubled. Calculate the final temperature, calculate the mass of hydrogen. Number 5, 2 containers each of equal constant volume are connected by a tube of negligible volume. When the temperature of the both containers is 27 degrees Celsius, the pressure of gas in the container is 2.1 into 10 power raised to 5 Pascal. One container is heated to a temperature of 127 degrees Celsius, whilst the other is maintained at 27 degrees Celsius. Calculate the final pressure in the container. Number 6, the kinetic theory leads to expression for the average kinetic energy of a molecule of the gas. E is equal to 3 over 2 into kT. The constant K does not depend on the type of molecule. Can this result really be true both for the hydrogen and chlorine? The mass of a chlorine molecule is about 35 times that of a hydrogen molecule. Explain why. There are 2 more questions in the exam style questions for this section for the next video.